once you finish your graph, we can go on to the next assignment. And here you're going to find the power in your electrical system. So from our reading, we know that power is equal to voltage times current, and that's measured in watts. So what we can do here is we can use a spreadsheet to do the calculation for us. So in each of these boxes, you can have a number or a calculation. So to do a calculation, we're going to put equals, and then that tells it to do math. And then once we put the equal in, we're going to tell what numbers we want to multiply by. So we want to do current, and then we'll do the time symbol. We'll just click on that box B2 and then the time symbol. And then we want to multiply by voltage. So we'll click on that box A2, and then we'll hit enter. Now you can see here that there's a suggested autofill. And that's what it's doing, is saying, hey, if you want to multiply these two numbers, I'm guessing that the next box down, you want to multiply the two numbers that are underneath the first two. And you can say accept it, or I'm going to say no in the second, because I'm going to do it myself. Another way to fill it is say, hey, if I want to do this pattern of multiplying those two numbers, I can do that by pulling this little blue square, and I'm just going to pull it all the way down. And then what it does is fills it down. I always like to check these. If I click in here, I can click in the formula bar, and then it highlights what I'm doing. And yep, I want to multiply those two together. So it's a quick way to use a spreadsheet to do the multiplication for you. Now here's a lot of decimals. We may want to straighten this up. We can use these buttons to do more or less decimals, but we'll give them all 2 decimal places. Same thing here. I like those go 2 decimal places. And you can also see that it adjusts on the graph. If you don't like that to adjust on the graph, we can tell it to, we can go to edit chart, and we can go to our series, customize, and then under our series here, I believe it's chart, is it chart style? No, it is vertical axes. So we go to vertical axes down here, there's a number format. It says from the data source. So it's matching whatever we put in here. But if I want to get rid of these, I can change it here. I can say, look, let's just do numbers. I can do whatever I want. I'd like to just put in, I'd like to do other custom formats, and then I can just choose what I want. So if I just want numbers without decimals, I can just do that, and then I hit apply, and now these numbers don't have a decimal after it. So it just makes it a little easier to read. Again, you can some bold things to make it look nice. You can center them. And then that goes here. So now we calculate the power. The next thing that asks this new assignment is to find the resistance of the wire. So we learned here in class that the resistance of the wire from Ohm's law is we have voltage is equal to current times resistance. If we look at this from, if we remember this from geometry, we also have an equation of a line. Y is equal to mx plus b. And now if you remember that, that's the equation of the line. Well, if we want to know what the resistance is, this R, we can see that's actually, if we look at the equation below, V is Y, voltage is our vertical axis, I is our horizontal current, which would be our X, which means the number multiplied by I, R, must be M, which is the slope of this graph. And of course, we don't have a B, so that's like saying plus 0, so B should be 0. And if we look at this graph here, it looks like it's going to have an intercept around here at 0. So what we can do is we want to find the slope of this graph, and that will be equivalent to the resistance in our wire. So there's a good way to do this in here. If you go to, we can go up here to edit chart, and if we go to our series, let's go to customize again. If we go to our series, we can go down, and there's something called a trend line, so we can put that in here. And for label, we want to use the equation, and we can even show the R squared if we want to. We can talk about what that is, a measurement of how well this data fits on a line. And so when we look at this equation up here, there's our intercept, B. It's close to 0, so that's kind of a good sign. It's actually a little bit negative here. And there's our slope, 1.09. So from this graph here, we can say the resistance of our wire, which is equal to the slope of the graph, is about 1.09 for this example. So 1.09 ohms. And so that's a way that you can find the resistance of a wire using our data of voltage and current. Now the last question here says, use the resistance in Ohm's law to find the heating power of the wire at 10 amps. So if we know that we want 10 amps through our wire, and we have Ohm's law, it equals I times R. If we put in what we know, we can find the voltage. So voltage V, our I from the problem says 10 amps. And then we got to put in our resistance, which we just found, 1.09. And if we do that math, we can see that the voltage we would need would be 10.9 volts. Now once we know that, we can find the power. Since power is equal to current times voltage, we can put our numbers in. Power is going to be, the current that we want is 10 amps. The voltage we would need to get through our wire is 10.9. And putting that together here, we can do that. If we want to find out, have the calculator do it, we can just write 10 or equals 10 times 10.9, and now it acts like a calculator and just does that math for us and puts the answer down. So 109 watts would be our answer. So an example of how to use spreadsheets to do some math for you.